Thank you. Good afternoon. We paid to take this post-lunch session. I hope you'll all be very quiet, but that's on the lighter side. This is a very, very interesting topic. Unfortunately, all my lines were stolen already by the gentleman out there when he introduced the session. It's a very contemporary topic. Supply chain, like he rightly mentioned, is the lifeline of many things that we experience in day-to-day life, and they are really the unsung heroes. So today's topic is about how technology and specifically artificial intelligence and the edge play in kind of shaping autonomous and intelligent supply chains. It cuts across a lot of industries, so it requires no real introduction. But in an age where practically, we expect things to be delivered and we expect things to be serviced at a jiffy. Gone are the days when somebody would wait for a week for something to get delivered. How does that happen really in the back? If you really look at it, we are in the midst of a very interesting time. On one hand, there are technology advances. On the other hand, if you look at it, there is a lot of challenges that have come up as well. I don't want to preach the car out here, but then look at the supply chain challenges that have been happening across the board. There are geopolitical challenges because of wars and things that happen in the seas. There could be one ship that could just go astray and then block the entire world, for about 2 weeks, just one ship. There is political tensions in the South China Sea without really going into the political aspects of it. All of this have an effect on us. On the other hand, if you look at it, the very aspect of sourcing has changed. Companies come back with very different sourcing strategies as well in terms of being able to diversify the sources, also to kind of de-risk, where they can go from and source things should things go wrong. And all of this kind of fortunately has a very good technology in the back. You have a lot of technology that enables you to understand how and where to get things at a very, very optimal space. So, if you really put all of this together, the aspect of technology pervading something as core as a supply chain and logistics in terms of how do we make them more resilient, how do we make them more autonomous, how do we make them more intelligent, and how do we make them more sustainable as well is an extremely important topic. And we're just fortunate in being joined by 3 industry stalwarts out here. So really like to kind of start off with the aviation industry, if you will, with Hari coming in from Boeing. Hari, to start on a lighter side, I was once in a plane, and this is a true incident. It was an Airbus, not Boeing. And my colleague, I was in an engineering services at the firm at that time, my colleague said, when we were almost at the top of the runway, he said, these 3 things were tested by our company. Our company basically tested. I'm like, why didn't you tell me when we were at the gate? I would have got off the plane. So it's a very mission-critical industry, as you rightly said some time back. It has zero tolerance for errors. Barring some unfortunate incidents, it's something that basically has a high degree of precision. And you were just basically mentioning some time back, you have 1 million parts coming together and in one single place. Everything has supply chain and logistics written all over it. Would be very curious to see how do you leverage technology to make things better, make things more resilient, and what are your experiences through some use cases, if you will?
Again, thanks for the opportunity, right? What I'll do is, it's a huge product, to really simplify in 2 minutes is a challenge. So I'll look at 2 elements. Unlike the traditional industries, the life of a plane is really large. As I said before, it takes 15 years to design before it's ready to fly. 15 years, that's a significant amount of time. And once it's up there, it flies for next 50, 60 years, okay? So a lot of returns. So what we really do is, and given the the smallest aircraft has 750,000 parts, okay, and then the biggest one is 2.2. We can't do everything in all, okay? So we rely a lot on our supplier networks to do that. And we do that through our global suppliers, as you saw about the sourcing. We operate out of close to 70,000 suppliers in 85 plus countries. The shipping aspect of it. So the critical aspect, which is, we get into a lot of contracts, okay? It's a contracts is where we are looking at more of the digitization to help us. All the way from signing up a contract, how do we take some standard terms and technologies, and how do we accelerate the contract signing, as well as ensuring the performance to contracts. And trust me, these are not small pieces of paper that a human can read. You all can excel. Each of them has a legal implications and contractual stuff. So that's one area I can, definitely we feel we are leveraging the latest AI tool sets to really help us accelerate and bring on value, both from, design wins, as well as ensuring the performance to the contractual terms and conditions and everything else. And that's one area, and I'll talk about the use cases in the subsequent questions. That's where, we work a lot.
Wonderful. That's very interesting. You would have thought you would have mentioned something a lot more very, very cool, but something as important, as basic as digitalization in contracts, because you really hold them to the terms. That's very interesting, and how technology is helping that is something that we can definitely foresee. Absolutely. Now, thankfully, we have a diverse industrial background out here as well. One can't help wondering. Imagine, nobody wants to really remember the pandemic anymore. We've all kind of come out of it. But imagine 2-3 years back, if there is something that happened with the supply chain and the logistics behind, and there is no food on a table. That happened with some people, unfortunately, but I think most of us did not have that problem. Imagine what all things happen in the back in terms of, you talk about supply chain resilience, I think there is no better example than what happened during the pandemic in terms of everybody being able to have, their course of food. The food industry and in the FMCG industry in general is something that also has its own set of use cases, its own set of, way you approach it, because there's a lot of perishables, there is a lot of taste, there is a lot of local sourcing versus global sourcing, things like that. Very curious to know, how have you been applying technology at Kellanova or in the industry in general, Nithya, in terms of bringing all that together?
Yeah, thank you, Madhavan. See, ours is a typical food industry, right? And when we talk about food industry, we talk about, food made to consumer preference in the right quality, right? And therefore, right, all the parameters related to supply chain, be it, safety, be it standards, be it regulations, etc. And all of these are super critical. And supply chain in general for a CPG industry is very important, not only for cost optimization, but also to stay competitive, right? So talking about what we do at Kellanova, as you rightly stated, right, food is a very, very contentious, commodity, because, we can't relate much here in India, but elsewhere, right, any non-food item, right, in your food packets are going to create a lot of litigations, right, a lot of problems for you. So therefore, ensuring there is significant amount of safety and quality across our supply chain is very important, and AI is helping us do that. And all of this is apart from the regular use cases of cost optimization, supply chain control tower visibility and actionability, etc. A couple of things that I thought are also very relevant across supply chains right now is resiliency and sustainability. Right? And see, COVID and even before that, the global, recession or financial crisis, or of late, all the geopolitical things that are happening around us has taught something very crucial, which is how much ever you try to prepare yourself in terms of, having the best AI models forecast demands, shit still happens. Right? And let's admit to it, right? We could never have forecasted COVID or anything of that sort. So what remains important is how resilient our supply chains are to that, right? So, and therefore, in our case, right, we have completely digitized our supply chain. We have a end-to-end supply chain visibility. We know what our supply chain flows are. We know where our vulnerabilities are, and that really helps us kind of be proactive in terms of responding to scenarios and situations. Another one is in terms of sustainability, right? Kellanova has a target of 100% green energy and 100% recyclable packaging by end of 2030. So that's a tall ask, and then what we are trying to do is ensure that we bring a lot of AI, a lot of big data into the ecosystem in order to measure our carbon footprint, our emissions, our water consumption, etc. And also in terms of package technology, we are using AI to kind of do a lot of R&D in that aspect. Yeah.
Wonderful, wonderful. No, digitization, digital visibility across the value chain, and to your point, I think using AI and big data for being able to measure your sustainability. I mean, I hope I won't hijack the session into sustainability, but that's such an important aspect in terms of how the world needs to approach this whole thing. And so on one hand, we have a shelf life of 50 to 60 years and supply chains for that. On the other hand, we have a shelf life of 3 days and the supply chains for that. And amongst all of this, we have somebody who's just playing with toys and robots all across the floor and things like that. So at Ati Motors, the way you kind of shaped up the company in terms of how do you enable a lot of these supply chain aspects and the logistics aspects inter, across the value chain, including using robotics and including the AI into it, into intelligent robots and things like that. That was a very interesting concept, Saurabh. So do you want to kind of talk about what first triggered you to kind of get into this space and how effective has it been, with the help of a couple of use cases?
Sure. So, when I started, basically, I started in 2017, and the thinking was that whatever moves is going to be autonomous, right? I think we are getting into that stage in this world where everything which moves, and you are seeing that slowly. Various stages of autonomy will come into that. So it felt like an exciting time to be an entrepreneur in this space. It feels like 1994 on the internet. So that's primarily why I came into it. Multidisciplinary engineering, that's another thing which is exciting. Various streams come together to make something like this happen. You need mechanical engineering, electronics, AI, robotics. All of these have to come together to create value. Where manufacturing and robotics is moving, traditional robotics was all about a lot of precision when your environment doesn't change, right? So I would distinguish between, say, automation and autonomy. So there's a lot of automation where you will do, say, 1 million operations a day to a micron level precision, but nothing changes around you, right? You control your environment. But autonomy is good at doing something like that, maybe with lesser precision at times, and you will accommodate that in the process flow. But when things are changing all the time, you are doing it together with humans, with dirt, in the open roads, etc. also, right? And that is only possible with AI, right? So handling, otherwise you will be very precise in your control systems or in your instructions, go forward 5 mm, right? But no, in the real world, it's going to be, there is something and I want to be close to it. And that all that basically becomes very, very, very much a thought process which comes with AI into it. And all the factories need that. Manufacturing is moving towards dark factories that's an idealized concept right now. I would say there's no truly dark factory, but slowly factories are getting darker and darker. Let's put it that way. And it's all going to be driven by these robots which have to go around and do things. The other part is that manufacturing also needs huge amount of flexibility. Today, like you mentioned, right? The resilience that you need in manufacturing comes from flexibility. If everything is rigid, then you're not flexible. Then how do you get flexibility? Then you need robotics which is not fixed to do things, but which can move around, which can be repurposed, routes can be changed, production plans can be changed daily, not just weekly, right? Or not yearly. Right? So how do you do that if your robots are not doing kind of things that self-driving cars are doing on the road? Now, self-driving cars have been a long way coming and still are not, but I think we use that kind of a technology, and when we found that we apply it in the context of B2B context in manufacturing or warehouse, we do manufacturing, but companies are doing in warehousing, they are much more tractable problems than, say, what Waymo is doing, right? So you can't suddenly put self-driving cars in a lot of countries, but you can do this now. I mean, our robots are running across US, India, Southeast Asia, right? So you can do these things in B2B use cases, so they are real now.
Wonderful, wonderful. No, that's a good learning in terms of how do you separate out automation from being autonomous. And even in countries, including in India, where regulations or just practicality doesn't allow you to do a lot more automation on the roads, how is it still very, very effective within controlled environments? And what I liked about my takeaway was also the fact that, while I think your industry is all about precision, and it's not that you sacrifice precision, it's about how do you build around it, including, you should be talking to Tesla when they said that, the thing that really is obstructing that it in India could be anything. It could be an auto, or it could be a scooter, or it could be a bullock cart, or whatever it is, right? So I think the maturity that the technology takes in these things is kind of, what to be watching for. Now, that kind of leads me to kind of, go into a slightly different segment and to make it more practical. I think it's great to pick up the use cases that the 3 different industries offered as it pertains to supply chain and logistics. What I like about supply chains and what I like about these industries is the fact that, I'm being very honest and open out here, artificial intelligence, generative AI, they're a long way to go. It's an evolving technology. And sometimes it's just fanciful to talk about it. But you are basically using it in practical circumstances and kind of finding it effective. So whether it is AI, whether it is edge, whether it is any other aspects of, having even security built into it and things like that, when you implement it, you encounter practical challenges. I think the learnings for us could be far more accelerated when we learn from the challenges because we're then applying it for a specific context. So very curious to know what would we are top of the two, mind challenges that you kind of solved using some of these technologies in your work.
So let me take a couple of minutes to articulate, right? We spoke, as I spoke about the number of aircraft parts we have, and also gave the background this exists for 50, 60 years. So if you look at most of the aircraft that are currently flying were designed in 70s and 80s. And the regulation needs for, a little bit more technically, the master data and information around it, has been a big challenge because all the systems, MRP systems, your manufacturing, your, ERP systems have been there for decades. But what's evolving around us, the use case that we are dealing with is around dangerous goods. So that's a regulatory body. Take all the countries in the world, whether you move whatever is a dangerous goods, the definition can vary depending upon the type of chemical, the gas, or even the crystal gels to silicon batteries. When you move it by a road, rail, sea, and the air, they have very different handling characteristics. So what we have been tasked is, and then take this of the millions of parts and apply the regulatory of all those 100 countries who don't really talk to each other. Yeah, Europe has a standard. So what we are trying to do at Boeing is we just got into services. So far, we are producing flights for 100 years, which was, good thing because our suppliers took care of all of these things. So now we wanted to get into services, and we realized that, oh my God, this is something we need to figure out now, because we are sending our parts to our operators globally. So we have embarked on a mission where we got all the parts for all the models, and we got it down to an, sort of 36 plus million parts. We got to skim through whatever somebody wrote in 80s to how good it is today. We got to crystallize that, and we have to apply. That's where AI is really helping us. If there's a commonality of a part, that came from a supplier which has very similar characteristic on the same type of aircraft, same engine, and if that is classified as a certain type of classification in the hazardous material, whereas this is not classified in this system, would you like me to make a recommendation? So it's the same learning process, right? So we have the team that's working to compare. Now, you can do this crisscross. I'm not a statistician guy. The ML guys would know that. You take this millions of parts and try to correlation. It's a massive job, memory intensive, processing intensive, where they're trying to make but however, how much intelligence you put into that? The government says, finally, it should be a human who should check that box. Okay? So even though we have done a lot of work on the AI to help us skim through, it's a massive project, millions of dollars, because one violation or one escape, we call it in our industry, can lead to notification from FAA. And it's more dangerous when such part flies on a commercial aircraft with people and it's not appropriately tagged. Okay, it's very different, that's what I said. So we are in this massive investment project where we are doing it. AI has certainly helped us skim through this, but we are still constrained on, the human capital to go check, because federal government says it should be human that should finally decide. We can provide all the intelligence. So that's one great use case where, technology is really helping Boeing a lot, in ensuring that if at all a dangerous goods is on an aircraft with people, it can fly in safe, with no threat to the people. So that's one use case I thought I'll just articulate here, given the short time.
Absolutely. No, that's very, very insightful. Firstly, am I glad to hear that the federal government is mandating that humans are still involved? That's a different story. But be that as it may, I think, just hearing what you just said, it's so insightful. About 36 million parts, and you digitize them, and then you use AI to classify them, and then you try to apply the compliance and regulatory laws of 100 countries on top of that, and ensure that every single aircraft is compliant to it, right? Every single thing that...
The type of transportation.
The type of transportation.
It's much more easier on a rail or a road versus an air.
Right.
So you got to determine that, yeah.
Absolutely. Amazing, amazing. So I think a classy use case in terms of, how technology helps solve very real problems. Fantastic. Just to break the monotony, could I go to Saurabh first and then come to Nithya? Yeah. So Saurabh, in your world, what challenges? Robots, for God's sake.
Yeah, the robots are tough unless you're like doing predefined videos where they dance in the real world. I'll give you maybe a couple of problems which we have seen. I mean, there are problems every day, but a couple of problems which I've seen in the last few weeks. Okay, something which would appear as trivial when you go on the shop floor, what can happen. So we are doing a robotic movement of a PCB assembly in one of the electronics manufacturing unit. And the final thing has not happened, so the customer is very careful that we should not give any shocks to the assembly. And when the robot goes, the cleaning people have cables all the time on the floor, and it's a third party, so you can't control when they put the cables or not. And they're like, and we are in India, right? So we have robots which can work on broken roads, okay? So we go over cables happily, but now the customer says, don't go over the cables because we get a shock, and we don't like those shocks on our PCBs. And the cables are much smaller than the safety requirement for what you need to typically stop at. So now, well, you look at that problem, you take the data, you train a new AI model, come back in 2 weeks, and you start observing cables and stop, right? Then you will notice somebody puts a cable where there's a pedestrian crossing, and then it's black on white, and you can't see the cable. So these are everyday problem, but it can be done using AI because nobody's doing, you basically can throw data at the problem and solve it. So that's why I wanted to give this problem. It looks trivial, but if you were to solve it using classical techniques, very difficult. But because you're using AI, it becomes much more easier because you can just data the heck out of it, basically, right? I mean, there's no other reason, no other way to solve this. The other is we are so used to vision these days on AI, but when human beings do stuff, we rely a lot on tactile feedback. And everything can't be done with vision, right? I mean, like for example, if somebody is taking wires around something and doing it, right? You're feeling your way. That's something that robots can't do well. It's very difficult. We don't do that even today. But even when say someone is using a forklift, a simple thing as you may have a shrink wrap on a pallet, and the fork of the forklift will pierce through the shrink wrap. And how does the piercing happen? Because the guy is feeling, say if there was something behind it, the guy will stop, right? And so the person, even through the machine, has enough sense, yeah, the machine is making a little more hum. Is there something I should stop? So the human beings have a very natural sense of tactile feedback and physics in the world, which AI models still don't have, right? You don't even have very good sensors today which do this. And so this is a place where we are actually trying to see if we have to make a sensor which can do something like this, which can give us the feedback, and then we can train an AI model to do, right? So they're like a lot of, I mean, sort of a trivial problem and a problem which is not solved, and people have to solve them, right? So I thought I'll give you two of both.
Wonderful, wonderful. Not trivial at all. Not trivial at all, to be honest with you. I think great examples. And just as a small digression before we go to Nithya, you just touched upon something. I'm personally a fan, and my company also researches. It's an R&D company, Zentience, and it researches a lot into what we call as augmented intelligence rather than just artificial intelligence. To your point about human beings, I think the human augmented intelligence, if there is a way to accelerate that into kind of getting that into the system, I honestly believe aviation industry did that quite a long back. I don't know why the other industries have not followed through, but then that's a great way of kind of accelerating and kind of getting the human and the technology elements to accelerate innovation much, much faster. So great, absolutely great examples. I mean, I'm sure we can talk all day about this, but given the limited time frame, we'll take the rest outside. But Nithya, what challenges? Your industry is all about only challenges. I think all your use cases are only challenges. So.
No, I would not say after hearing the challenges elsewhere. I think we are much simpler and less problematic. But yes, we do have our share of challenges. Right? I keep saying, right, what we see from AI is the outward result of all the hard work which has gone underway. So there's a lot of undercurrent below the AI that people or the business see. And that's all the fundamental challenges that we got to solve on a daily basis in turning those AI solutions. Starting from the complexity of our ecosystem, if you think about a typical CPG organization, right? They've got multiple markets. Every market acts like a company within a company, right? They are highly federated, highly siloed systems, right? This is a complexity which reflects in the data that we consume to build our AI systems, right? So I typically say, right, there's a paradigm which states garbage in is equal to garbage out. I can say that about complexity. Complexity in is equal to rather complexity squared, right? So there's a lot of complexity that we deal with in terms of our data, in terms of our processes and ecosystems. Having said that, there is another complexity. It's like peeling the layers of the onion, right? You address the data and the system complexity, then next comes your integration problems, right? So we are a traditional organization, we have got a lot of legacy solutions running, right? How do we integrate the new kid in the town, right? The new toy in the room, the AI that we have developed, right? The generative AI that we have developed. How do we integrate that with the existing legacy solutions, right? That is again where, the next level of challenge comes. And then once we are able to peel this off, then the next is in terms of adoption and data literacy across our organization, right? So I'm not even talking about talent, right? Talent is something which probably, we can either build or we can kind of, buy or outsource or whatever we want. But within the organization, people who have to adopt to these AI systems in order to generate the outcomes and generate the desired ROI, how do I ensure that they feel comfortable with these systems? How do I manage that change for them, right? So these are the various levels or layers of complexity that we got to deal with, right, whenever we kind of do any sort of these cutting edge AI solutions. Yeah.
No, very practical. Sometimes it's just flashy to talk about autonomous and things like that, but if you can't solve for these things, you just don't get to the next step at all. So it's as practical as it can get. Now, I think this is pretty useful. Now, just to summarize, what you guys don't see out here sitting there is a giant clock with a sledgehammer at it. So if you don't finish on time, it's going to hit us on the lighter side. But just to summarize, I think the bigger takeaways out here are really digitization, all the way from contracts and things like that, digitalization of parts, classifications and things like that. A lot of aspects of how do you, solve for local problems and how do you solve for things that are not in your regular scenarios using AI, using vision. How do you augment them with human intelligence wherever it is possible? And how do you basically go back into kind of solving for practical challenges of integration into traditional systems as much as you're innovating on using big data and analytics and kind of ensuring that your supply chains are resilient and the logistics behind them are resilient. I mean, that's, if you really look at it, the bigger summary and the takeaways from this discussion. Like I said, we could take all day long and keep talking about it all day long, but given the time constraints, I think this is very insightful, and to get perspectives from 3 different industries, and 3 very, very, supply chain rich industries has been very great. It's just making some keywords, noting down some keywords. And if you really look at today's topic, it's like autonomous, intelligent, resilient, smart, secure, sustainable supply chains. If you have to create an acronym out of it, I think it'll look like an airline PNR. But I think each keyword has so many technologies behind them, has so many use cases behind them. And I think the learning from here is, how do you take the use cases and the challenges surmounted from one industry, apply it in your own way in the other industry, and how do you keep innovating on that? I think if we could just solve for it, we'll start working towards a more, better and a more resilient and a more sustainable world. So thank you so much, Hari and Saurabh and Nithya, for being part of the panel. And thank you, NASSCOM, and thank you all the attendees for, paying your attention post a very good lunch. If there is any one question that anybody wants to ask, we have exactly 1.5 minutes to go. Yes, the hand went up there. 1.5 minutes for your question and the answer, sir.
Sir, I'm Chandrakant. Just want to check, morning we have a lot of sessions. So how AI is going to help our young generation? So any R&D, any subjects which empowers them to enter into this industry?
Sure, thank you. Does anybody want to take 1 minute and 8 seconds? Go ahead, Saurabh.
I can try. I mean, I think it's AI, to look at AI as an industry probably is not the right thing, in my opinion. AI will impact every industry, right? So I think the way youngsters will look at AI is like software programmers will code with the help of AI. Writers will write using the help of AI, right? So getting into AI will become a very specialized thing. You have to do computer science, master's, PhD, etc. So that's the way to do it, right? I mean, if you want to contribute in AI, please go do a PhD at whatever, IIT, Stanford, ISC, etc. But if you want to generally use AI to become better, everything that you do will become powered by AI. So become used to the tools, etc. Whatever was getting used yesterday is not going to be relevant tomorrow, unfortunately.
And just to add on it, luckily, the youngsters, right, who are getting passed out today, partly I feel jealous because they have got so many tools in their hand which probably we could never have imagined when we passed out of our college. And all of these tools are open source. I mean, I would rather say most of these really kind of powerful tools are open source. So they have got the world in their hand at the click of a button. They can self-learn, they can learn as a community, right? And they can have, they can also kind of contribute back, because, open source is like a highly democratic way of building the software collectively, right? I would rather say they are in a very good place.
Absolutely, absolutely. No, thank you so much. Thanks for listening to the session. I hope you found it useful, and thanks my co-panelists.
For more content on tech and leadership, subscribe to NASSCOM YouTube channel and press the bell icon to never miss an update.